Hello there, my name is Mrs. Jenkins. I wanted to take a look with you today at solving equations with variables on both sides. We're going to be solving for the variable in these equations, and we're going to have several different variables, but our goal remains the same. We want to get that variable all by itself, even though there's a bunch of them. Get it by itself on one side. Well, how exactly are we going to do that? The first thing we want to do is add and subtract terms so that we get the variables on one side of the equation and the constants on the other side of the equation. Doesn't matter which side each is specifically on, just put them on different sides. Then you'll multiply or divide to completely isolate that variable. So we'll add and subtract terms first. So when we take a look at our first example here, we see we have a 2x on the left side and a 4x on the right side, both containing a variable. Then we've got our constants, a positive 7 and a negative 7. Now we want to get the variables and these terms, the yellow, on the same side, the green on the other side. Doesn't matter which way we move it, but I'm going to go ahead and start by subtracting 2x from both sides. Adding and subtracting here. The reason I subtract is so that this will cancel out. 2x minus 2x drops out, leaving me with just 7. 4x minus 2x is 2x. Well, I've got the variables together on one side, but I want to get that negative 7 over on the other side, so I'll need to add 7 in this case. When I go ahead and do that, it will drop out here, just leaving me with 2x. 7 plus 7 is 14. So now you can see we got the constants together on the one side. We got the variables together on the other side. Now we're ready to multiply or divide to get that x entirely by itself. When we go ahead and divide both sides by 2, that will cancel here, and we'll have that x is equal to 7. And 7 would be our answer then for our first example.
So again, the basic idea what I'm going to do in this case is I'm going to get my x's all on one side, and then I'm going to basically divide by whatever coefficient's left. So as a general rule, the first thing you'll do in these problems is get rid of the parentheses. So recall I've got to distribute 5 times 2, and then I'll take the 5 times the positive x. 5 times 2 is 10, and then 5 times positive x, well, I'll just get plus 5x. On the right side, I'm going to get 3 times 4, which is 12. I'll get 3 times negative x, and again a positive times a negative is a negative. 3 times x is 3x. And now I'm going to get my x's on the same side. So I could either move the x's to the right side, or I could move the x's to the left side. I'm going to move the x's to the left side. So I'm going to add 3x to both sides. So I'll have 10 plus 8x, and now the x's are gone on the right. I just have positive 12 hanging out. And again, my goal is to get x by itself. Well, there's a plus 10 hanging out. I'll subtract 10, subtract 10. The 10's again cancel out. I'm left with 8x equals 12 minus 10, which is 2. And again, now I'm multiplying by 8. To undo multiplication, I'll simply do division. So I divide by 8, divide by 8. I'll get x equals 2 over 8, which I can reduce down to 1 over 4. And that will be my solution in this problem. Okay, so again, the basic idea, get rid of parentheses, move your x's to one side, move the numbers to the other side. If there's a coefficient on the x term, which means it's either being multiplied or divided by a number, simply get rid of that number.
In this first problem, we would start solving balancing through the equals by distributing through the parentheses. This would give us 6x plus 2 equals 3 times 2 is 6x, plus 3 times 1 is 3. At this point, we like to get the variable all on one side. We can get rid of 6 positive x's with 6 negative x's, and subtracting 6x on both sides of the equation. Notice the 6x's subtract out of the left, leaving just 2, equals 6x minus 6x subtracts out, leaving just the 3. This is interesting. The variable has subtracted out completely. What we're going to be interested in is this resulting equation. This says 2 equals 3. Notice 2 does not equal 3. That's a false equation. If this 2 equals 3 is false, then the original equation must also be false as well. Basically, this translates to say that it never works. Because 2 never equals 3, we say this will never have a solution, or there is no solution to this equation. Let's take a look at another example. Again, in this problem, we'll start by balancing through the equals, and then distributing through the parentheses. When we do, we get 4x plus 1 equals 2 times 2x is 4x, 2 times 3 is 6 minus 5. After distributing, we check to see if we can combine like terms. On the right side, we see we have 6 minus 5. The equation now reads 4x plus 1 equals 4x plus 6 minus 5 is 1. Again, at this point, we like to get the variable all on one side. We can get rid of 4 positive x's with 4 negative x's. When we do that, we see the 4 x's are subtracting out completely on both sides. On the left side, we're left with 1 equals. On the right side, we're left with 1. Again, with no variable, we won't be able to determine what the variable equals, but instead we'll look at the equation and ask, does 1 equal 1? Yes, it does. We get a true statement. Because 1 equals 1 always, this is always true, it also suggests that the original equation is also always true. Because it's always true, we will say there are infinite solutions. Or sometimes you'll hear people say all real numbers, which simply means if I can get rid of this pop-up, which simply means any number that you can plug in for x will make this equation a true equation. So in conclusion, what we're seeing is if the variable subtracts out completely when we move everything to one side, we will either have an infinite number of solutions if we get a true equation, or no solution if we have a false equation.
The following video asks us to graph the line y equals 1/3 x minus 3. To do this, we're going to use the slope-intercept form of a line, which is y equals mx plus b, where m is the slope and b is the y-intercept. So, in this case, the slope is 1/3, and the y-intercept is -3. So the first thing you always do on these problems is to graph the y-intercept. So we're going to go over to that line that is on the y-axis, and the y-axis is always the up and down arrow, right? You see you've got two arrows on there, one going horizontal and one going up and down. And the up and down is the y-axis. And so we're going to go down -3 from the center, and that's going to be our y-intercept. The slope, 1/3, is what we deal with next. And the slope is the rise over the run. The rise in this case is 1. The run is 3. So we're going to go up 1 in the same time that we go over 3. So you go back to our y-intercept, and we're going to go up 1 and then to the right 3 and make a point. And then we're going to do that again, up 1 to the right 3. And actually, you can go the other direction and just do the opposite, down 1 to the left 3. and down 1 to the left 3 if you wanted to keep going. And we draw in our line, and that gives us the graph of y equals 1/3 x minus 3. That's what that line represents, is that equation. So we're going to do another one of these, and we're going to use y equals mx plus b again. This time the slope is -4. And whenever we have an integer, we always do -4 over 1, which you'll see in a second. And then our y-intercept is 5. So we're going to, when we do slope, it's always rise over run. And so we need to find a run. Well, anytime you got an integer, you just put it over 1. Okay, so we're first going to graph the y-intercept, which is 5. So we go to the y-axis again. And we make a mark where the y value is 5 on the y-axis. Then our slope's -4, so our rise is -4. So we're going to go down 4 because negative means down. And then you got to go to the right one. And then we're going to go down 4 again into the right one. You've got to go to the right one or you're going to mess up. So we can draw a line between those 3 points, and that represents the graph of the line y equals -4x plus 5.